getting rid of it. So it started out as a detoxification mechanism, but you could think of this detoxification mechanism, and suddenly when eyesight comes about, and these animals realize that they have this flashing thing, it's like a tool that was enveloped, and everyone started using this tool in different ways for different regions. So some people have used this tool as camouflage. There's some species that have photophores underneath on their underbelly, and they'll acclimate that to the downwelling light. So if you were to look at them from below, they would match perfectly with the surface. Some of them are using it to prey avoidance. They flash and synchronize their escapes, so all sort of the same way that schools would fish. They could attract and detect each other. They use it to kind of find specific species, as well as communication. There could be sex-specific signaling to draw them together. So there's lots of different functions or hypotheses of what bioluminescence is doing. In terms of the molecule that's doing it, I promise not to show any more chemistry after this, but just basic, it's two reactions. It's two components, luciferin and luciferase, and you mix these guys together, and you're burning off a fuel, and one's a catalyst. So this is your fuel, that's your catalyst, and the byproduct is light. So you're expending energy to give off luminescence. Unlike fluorescence, where you're not expending energy. And the story now of how bioluminescence and biofluorescence really collide comes together in this little guy. So this jellyfish, Coria victoria, is probably the most famous hydrozoan, to scientists at least. It has been immortalized in thousands, tens of thousands of scientific papers, and it's led to a Nobel Prize. This is about the size of my palm. They're pretty voracious eaters. I don't know if anyone's ever tried to grow a jellyfish, but it is quite difficult just because they're feeding all the time, so their energetic expenditure is quite intensive, so you've got to be feeding them all the time. And if you leave these guys for just a few days, they'll all just sort of cannibalize each other. And now, when you're studying them, in the 1960s, in terms of trying to find out what was it that's making these guys glow, there was a group of scientists at Princeton. You can see they even carry their Princeton colors, which I'm out right on the jellyfish, very, very, very stuck up with their jellyfish nets. But they went out there now, and they needed thousands, tens upon thousands of these jellyfish in order to find out, just to isolate just a few milligrams of this protein. And this scientist, who's also, you'll see him later, who also just won a Nobel Prize for this summer's work out here collecting jellyfish, was having great difficulty in order to perform a reaction on a bioluminescent species. First, you have to stop the reaction, because if it burns up, it's gone. Your component that you're trying to isolate